Super. Let's get started. First of all, a very warm welcome to every one of you who are going to be a part of this program. We're going to talk to you for the next 13 sessions, and that will span over a period of approximately 6 months. Sometimes it spills over and goes into 6.5 months because there might be a holiday or somebody might be missing or there's a cyclone warning or something of that happens. So invariably one session gets cancelled or postponed. And so we have a pre-launch session today, which was supposed to be a week back, and we had to postpone it for some reasons. And now the first session, which is really session 1, this is session 0. Session 1 will be on 9th of June, which is, well, exactly a week from now. Yeah, the next Friday. Now, as a math teacher, if we were to ask this question to ourselves, what really comes to our mind when we say mathematics? As a math teacher, if we ask this question, what comes to our mind when we say mathematics? We might say one of these things. We might say, oh, math, it's a very beautiful subject. It's got so many patterns. There are beauties which are out there in the world, which we can assimilate and understand because we have a good understanding of mathematics. And that's one thing which might come to our mind. And another thing which comes to our mind when we say mathematics is we could say that it's very creative, right? After some time, it starts getting into abstract creation. In the early years, it's a very physically creative space. And as we move forward into higher grades, it continues to be creative, but the creativity gets into a more abstract form. The creativity is more in our head rather than in our hands. And the third thing which comes to our mind when we say mathematics is it is about making connections. It's about figuring out, this variable, how is it connected to that one? And this problem is connected to what else? It's about making connection. And finally, math is like really fun. We could say all of these things as math teachers. Maybe we do, maybe we don't. I'm hoping, at least as math teachers, each one of us would be saying, math is fun, math is about making connections, math is creative, math is beautiful, and all of that is what we will say when we say the word mathematics. Now, the question is this. Is this what we hear outside about mathematics? When we go and ask somebody, how was your math, or what do you think about math, or what do you feel about math? Is that what they say? Very rarely people say that. You will hear words like boring. You will hear words like, or sentences like, I was really bad at math. I'm not a math person. All kinds of things we will hear. And it's a truth that math anxiety is that sense of panic and helplessness, okay, where we completely freeze in front of a problem. When given a problem, we don't know where to go. We have no idea how to approach it. And it creates a tremendous amount of anxiety. And that's a real thing. This anxiety has been measured by 2 people whose names are mentioned there. This anxiety has been measured by 2 people, and apparently 20% of people suffer from it. The 20% itself is not very important. What we have to understand is a very, very large percentage of people, 1 out of 5 people, undergo math anxiety. We are talking about anxiety. We are not talking about people who are disinterested in mathematics, right? 20% of people feel anxious when they are faced with a math problem. There might be another 40–50% of people who would just walk away from a math problem when given a math problem. Here we are focusing on people who suffer from math anxiety. Now, we need to understand this. If we want to reimagine mathematics, if we want to make mathematics fun, if we want to make mathematics beautiful, if we want to make it creative, it's very important we understand what is this math anxiety all about and how does it play, how does it work. How anxiety works in general and specifically math anxiety, it happens like this. First, we feel anxious, right? Could be for any anxiety. The first thing is we feel anxious. Once we feel anxious, our heart starts beating faster, the palms start getting sweaty, and there's a churning feeling in our stomach. When a child says that I have a stomach ache, we think the child is pretending. She's not pretending. All she's saying is that the stomach is churning, which is creating a pain. It's a real thing which happens. The stomach churns, the palm starts sweating, and our heart starts beating faster. Now, what that does is in our mind, in our brain, the amount of space which is available for the working memory, which is required for us to solve a problem, starts reducing. Once it is reduced, we have lesser amount of working memory for us to be able to tackle the problem in front of us. And when we have less mental capacity to handle the problem in front of us, what it leaves us with poor performance. Because we simply didn't deploy all the resources which we had. And that poor performance leads to greater anxiety. And we are back into the anxiety cycle. Now, this is a cycle which repeats over and over and over again. We feel anxious when faced with a math problem. Our hands start sweating, stomach starts churning, heart starts beating faster. It reduces the working memory and it provides less amount of our mental capacity to tackle the problem, which means we are not in a position to tackle the problem, leading to poor performance, which leads to greater anxiety, and we are back in the anxiety cycle. And that is what this whole cycle of math anxiety is all about. Now, one of the efforts we are making through this particular program, a program where three of us, Bhama, Sendil, and myself, who are a part of it, are trying to tackle is how do we make math more interesting? How do we reimagine the whole subject in a way that children are able to find it extremely fun to do math, and they find it creative and it makes them happy, and they're all saying, I want to be going for my math class. Okay, that's all we are trying to achieve through this particular program. Because our fundamental belief is that this cycle of anxiety has to be broken. And we truly believe that as teachers, we can break the cycle. This is not a cycle we have to be stuck in forever. It's a cycle that has to be broken, and the cycle can be broken by each one of us as teachers. This cycle cannot be broken by a handful of people. Which is why we gather around this table and say, what is that all the 50, 60 of us who are here can do together so that we can break the cycle of math anxiety and bring back the fun element by reimagining mathematics. And I want to say a word of caution, which is when we say the fun element, we are not talking about giving some color pencils to children and ask them to do this and cut this out and cut. All that is there as a part of it. We're not talking about that. We are talking about a process which is satisfying, which is very fulfilling for a child, that at the end of it, she goes back thinking, that was really fun for me to solve that particular problem. Right? For that, we have to go back and ask this question as to what is causing this trauma, what is causing this anxiety, what is causing this math trauma. There are a few causes which we have laid out. This is not an exhaustive set of causes, but these are 2 or 3 important causes which are there. The first thing is we unlike every other subject, we somehow say math and ability to do well in math is a gift from nature. That is, some of us are good at it and some of us are not good at it. So we think of it as a God-given gift, that math skill is a gift which you have been endowed with, and some of us are good and some of us are not good. And therefore, some of us who are not good start feeling this trauma. We say some people have a math mind or and some others do not have. We use all these terms, that he's a gifted mathematician. She's a gifted mathematician. She has got a math mind. Okay. That is one cause. Yeah, thank you. Somebody was, yeah. So that is one cause for this called a math trauma. The second cause for a math trauma is we define the subject by starting out saying it is a hard subject and it's also an uninteresting subject. If we have not said it in so many words, we at least make people feel that. By trying to solve a problem which is unnecessarily hard, and by solving it through a process which is complicated and uninteresting, what we do is the whole subject becomes A, hard, and 2, uninteresting. The reason for math trauma is also that we think of math in terms of right answers and wrong answers. We are way too focused on what is the answer and what is the right answer. And sometimes we mention saying that if you don't get the right answer, you won't get marks in mathematics, which is probably true. But math is not about answers. Math is not about, convergent thinking. Math is a very creative space, and that's what we want to explore. And it is not a space only reserved for nerds. This is a space every one of us can explore. The third reason for math trauma is somewhere there is an equivalence which is made, again verbally or otherwise. An equivalence is made that people who are good in mathematics are equated to smart people. If I were to ask this question, is Mahendra Singh Dhoni a very smart person? Many of us will say, yeah, he's a smart cricketer, but I don't know whether he's a smart person or not. What we are implicitly trying to say is he probably cannot solve a quadratic equation. It is not necessary. Smartness and ability to do mathematics well have got no correlation whatsoever. Somebody can be an amazingly wonderful artist. Somebody can be a great sports person. Somebody else could be very, very good in language. It is simply not necessary to think of mathematics as if I am good at mathematics, I'm smart, and if I'm not good in mathematics, I'm not smart. There is nothing correlating smartness to mathematics in terms of one of the 7 intelligences. One of the 7 intelligences is a conceptual analytical thinking intelligence. That particular intelligence gets measured based on how conceptual and analytical we are, and that is in mathematics. All right. There are many other intelligences which are there. The intelligences are interpersonal relationship, intrapersonal relationships, bodily kinesthetics, musical skills, spatial skills. There is a whole bunch of intelligences which are there. Out of that, just one of those intelligences is mathematics. And there is no need to unnecessarily put it in a pedestal, because in the process, what we are doing is we are losing a lot of people who could otherwise learn and enjoy this beautiful space called mathematics. So net, this is what we are telling our children, whether verbally or non-verbally. I want us to be very clear, because many of us will say that I don't really say that. We don't really have to say that. As long as we believe in it, it will go through our body language and we will be communicating that one way or the other. In any case, 80% of communication is non-verbal in nature. And as long as we are communicating that way, it will happen that way. So what are we telling our children? A, it's a gift. You either have it or don't have it. All right, maybe I don't have it. Next, it's a tough subject. And by the way, it's uninteresting as well. Okay, I don't have a gift, but it's a tough subject. Okay, maybe I can't do it. It's too tough. And finally, we are saying you're smart only if you're good in math. Then we say, okay, maybe I'm not smart enough. And that's how the withdrawal happens. The withdrawal happens if we say these three things. Okay, the game is lost even before we begin it. And these are both verbal as well as non-verbal. If you go and tell somebody, I'm going to teach you something which is tough, but some of you will be able to solve it because you have a gift that you can do mathematics. And some of the smart people, I can tell you, can definitely solve this problem. What are we trying to tell this class? We're trying to tell this class that 15 out of the 20 of you don't have the gift, or you're going to find it very tough, or you're not smart enough. And out of the 75% of the people who have been eliminated here, some of them just withdraw and go away and say, I hate math. I was never good in math. I was never a math person. I don't like math, all of that stuff. And 20% of them who give it a shot go through a trauma of, oh, I have to solve it. I go through the anxiety and poor performance and increased anxiety and keep staying in that particular cycle. Now, I put the pictures of 6 scientists, and each of these 6 scientists we can recognize. Charles Darwin, Graham Bell, we have Faraday, we have Einstein, and all these wonderful, great scientists. And the one thing which is common amongst all these 6 scientists, okay, they're great thinkers. They've come up with the most amazing discoveries, right? Coming up and, understanding and realizing evolution is an enormously, inspired finding. What Charles Darwin was able to do, or what Einstein was able to understand and, tell us what it is and discover, was all very, very interesting stuff and very, very intellectually, very high stuff. But all these 6 people struggled in mathematics when they were in their younger age. Every one of these 6 people struggled in mathematics. Da Vinci, arguably the most intelligent man ever born, struggled in mathematics when he was young. He is the person who later went on to be a painter. He was able to understand the biology of a human being. He was a composer. He built musical instruments. He invented a pair of scissors which we use today. It was invented by Da Vinci. There's a whole bunch of things which are attributed to him. And he was not very good in mathematics at his younger age. But as they grew, they were able to pick it up and learn it. So it is not necessary that smart people were good in mathematics and they had the gift and they were good from day one. Not at all. There were people who had the interest, who was not subjected to the anxiety cycle, and they were able to discover it within themselves. And they later went on to be really good scientists. Now, for that to happen, we have to first understand that math is not about providing short answers to narrow questions in a limited amount of time. This is the way we test the mathematical skill. But math itself is not about just providing short answers to convergent narrow questions in a limited period of time. That is not what math is about. Then what is math about? I want to make a case and say that math is about 3 distinctly different things, all integrated in a classroom as a math teacher. What are those 3 different and distinct things which we call as the 3 axes of mathematics? There is one axis of mathematics, which is formulas, procedures, and computations. right? When we are given a problem, we understand what that problem is, and we solve it through a set of formulae. So if you're given the radius of a cylinder, if you're given the height of a cylinder, then when we are asked to measure or find out what is the surface area of a cylinder, and then we might say, okay, going around, this will be the total surface area. Then there's a lid on top and there's a lid at the bottom, and both of those pi r squares have to add up, or some calculation we make. And that is the computational, procedural, formulaic part of mathematics. That's very important. But the fun in mathematics doesn't lie there. The fun in mathematics is really there on the other two axes. The two axes which are called the conceptual axis and the problem-solving axis. The procedural, computational, formulaic axis is important, but that is not all about mathematics. Because if mathematics is not understood conceptually, if you're not problem solving it and finally applying a procedure to get to the answer, most of the fun will be lost along the way. And therefore, it is important that we are able to integrate these three things. So remember these three axes. We will talk about it again and again during this Reimagine Math program. The three axes being, unless there is an element of problem solving, there's an element of conceptual understanding of what exactly is happening. I know the formula. I know the formula for finding out the surface area of a cylinder. But what exactly am I trying to do? What is that I'm trying to do conceptually? And what is this problem I'm trying to solve? Why do I need to know the surface area of a cylinder? Or what might it be? Before I have a formula, is there a way I can speculate on what it might be? If I'm asked to find the surface area of a cylinder and I have no idea what the formulae for surface area of a cylinder is, in which case can I speculate? Can I come up with some ideas? Okay, because that is the problem and I want to solve that problem. Can I approach it using first principles and come up with some kind of a methodology, some kind of a logic in which it can work? And that is what we want to be doing as teachers, where we are able to focus on all the three axes. Now that we will be focusing all through the Reimagine Math program, where we will talk about various explorations, some puzzles, and how to make connections, and so on and so forth. Now we'll also make it quite clear here. A, we are going to be talking about topics that are a part of our syllabus, which are all a part of our syllabus from grade 1 to grade 10. We are going to be talking about topics which are a part of our syllabus, or mostly a part of our syllabus. But there might be some topics that are not directly fitted in to our syllabus. Okay, but we will talk about those topics as well. The second, this is not a program where you as a teacher can find some tips and tricks by which you will be able to get your students to go from the current 80% to 95 and 100. The children will go to 100, but the path or the direction is, we are not taking specific problems and saying, okay, these are all the problems we should be thinking about. These are all the problems we should be discussing, because this might be asked in the, it is not exam oriented. It is not marks oriented. It is conceptual, problem solving, procedural oriented, and reimagination, creativity, happiness, and all of that oriented, which we believe will take the child to 100 marks. But we are not going to address it directly and say, how do I get 100 marks? Okay, because if you don't have the conceptual understanding and the problem solving, then getting the 100 marks is anyway not too consequential. Okay. Now, what will it look like? I'm just going to take one example and share it here, which is, let us say we talk about the sum of odd numbers. Yeah, the sum of odd numbers. Let us say, what is the sum total of 1 plus 3 plus 5 plus 7 plus 9? Which we know that there are 5 terms here, and therefore it is n squared or 5 squared, which is 25, which can also be computed through brute force. We can add up 1 and 3, which is 4, plus 5 is 9, plus 7 is 16, plus 9 is equal to 25. And you add 11 more to it, it will become 36, which is 6 squared. And add some more, it will become 49, which is 7 squared. And we can easily observe it. We can easily understand it and move on and say it is equal to n squared. What if we handle the problem like this? That what are we trying to solve? We are trying to find how many of these little squares are there. There's 1 square in row 1, then there are 3, 5, 7, and 9, which is nothing but we have 1 square, and then we wrap it with the 3 orange squares. Then we wrap that with the 5 blue squares. Then we wrap it with 7 orange squares, and then this. This is what is happening, right? So we don't need, while the formula n squared is quite interesting, now you see how it will stick. It will stick in a way in our head, in our brain, in such a way that we will never be able to forget it. That is the way we want learning to happen, that once we have learned it once, we don't forget it at all. It is like asking this question, how many times do we learn how to ride a bicycle? We learn it only once. How many times do we learn how to walk? We learn it only once. When we are 1 year old, we go through a trial and error and then fall and slowly try to get up and again fall and get up and fall. And by 1.5 years, most children are walking. And that's it. We don't relearn it. We don't have revision classes for walking. Okay, we don't come to the age of 10 and say, okay, we will now revise the whole subject called walking. Let all of us walk and be sure that we understand it. We don't do practice problems in walking. We don't say, okay, let us all walk for about 5 minutes and understand whether we can walk. We don't do any of that. We learn walking, we understand walking, the brain codes what walking is, and that's the end of that. There is nothing more which happens. Similarly, the sum of odd numbers have to happen pretty much like that. The sum of odd numbers, when somebody looks at it happening this way, it is going to stick and they're going to remember for life. And that's the end of that. There is no more requirement to come back and solve what is the sum of odd numbers. We don't have to solve 20 different problems starting with 1 plus 3 plus 5 plus 7 all the way to 53. How much is it? All of that is, we can do some homework. All I'm trying to say is it is more important to understand why it is n squared, how does n squared really come about, and to be able to understand it conceptually. Then any amount of homework and procedures and computation and formulae, the children will be able to do it quite automatically. There is no need for revising it or memorizing it or remembering it. None of that. There is no need for any of that because they have the tool now and they can do it. All right. Now, this kind of an exploration, what it does is it makes deeper brain connections. The reason why we learn bicycling only once is because it goes to a part of a brain where the connections are stronger and the connections are deeper in a way that we don't have to relearn it. Okay, mathematics doesn't quite go into that part of the brain, but let's assume and say that at least can we make some part of it go there so that it is almost instinctive when faced with a problem. If you ask the question, how much is 8 times 7? None of us is really computing to say it is 56. We know it is 56, right? It's automatic. Can we make some of this learning go so deep that learning resides and our ability to solve it is almost automatic? It's coming out of as if it is instinctively coming out, not from a very different way of processing computation, looking at the formulas and rote memory and the surfacial memory. Now, there is an important concept called growth mindset, which we want to talk about very briefly. Now, a growth mindset is a very intrinsic and a deep belief that all basic traits about a human intelligence can be developed through dedication and hard work. a growth mindset, which has been made quite popular more recently by Dr. Carol Dweck, and she talks quite a bit about it in terms of fixed and growth mindset. Growth mindset is simply a belief that very basic traits about myself can be improved, can be enhanced through dedication and hard work and effort. Okay. Now, when we provide the non-verbal cues to our children, what are the non-verbal cues we provide in the direction of people who are good in math are smart people. There are some people who are gifted in mathematics and some of them are not. Now, these are some of the non-verbal cues or verbal cues we are providing to our children, and that doesn't help in the growth mindset because they have to believe that through dedication and hard work, not by repetitively solving a whole bunch of problems. They have to believe that if I have the right amount of dedication and hard work towards conceptual and problem solving skills in mathematics, then I will be able to grow my skills in mathematics. And another thing which comes in the way is labeling. In labeling, it is labeling like these are high performers, low performers, smart kid, dumb kid, then fast learner, slow learner, all of this labeling. Every one of this. Saujanya, if you could mute, please. Saujanya. Mary, can you help me? Yeah, thank you. Now, any form of labeling, okay, we can all understand it is detrimental if you label a child as a slow learner and she or he come to know about it. We know it is detrimental if you call somebody as dumb. But what we don't understand is it's equally detrimental to call somebody as smart. You know why? Because what you're doing is you're labeling them as smart and they'll hang on to that label. For a child, teacher is like God. Okay, my teacher has told me I'm smart. What that means is I'm going to hang on to the label and not allow it to be destroyed at any cost. So when I'm faced with a problem next time, which is a tough problem, which I'm unlikely to solve, what will be my approach? Go away from it. If I try solving it, I might not be able to solve it, in which case my teacher might not find me smart at all. However, if I avoid it, hopefully the teacher will not be able to find out whether I'm smart or not so smart in this particular case. Risk avoidance is something which happens when we label somebody. We can, of course, praise effort. I'm not saying we should not praise our children. We should, of course, praise our children. We should praise them for their effort. We can say things like, oh, I really like the way you approached this particular problem. I like the way you didn't give up all the way till the end. I like the way you took the initiative to do something. I like the way, despite yesterday having a power cut, you were still able to find the time to be able to do the homework. All of that is fine. These are all praising processes. We are not praising a person. We are not praising a person. Instead, we are praising the process. And that leads to a growth mindset. So my request, teachers, all of you, is no labeling whatsoever. It doesn't really matter. We saw Edison, we saw Da Vinci, we saw Albert Einstein, we saw Faraday. Each one of these children, if they were a part of our class, would have been called as slow learners, would have been called as dumb. Think about it. Albert Einstein, slow learner, he was. It's okay. It is not necessary that we all have to pick up everything at the same pace all the time. That's perfectly fine. Where else are we going to try and fail if we don't try and fail in a classroom? We don't have too many other opportunities, which are welcoming opportunities for people to come out and fail. A classroom has to be a place which is very accepting of all kinds of children, which are children who have different needs. It could be somebody who is struggling with a certain matter. It doesn't matter. We don't have to judge. We don't have to call it as smart and dumb and fast and slow. None of that. The moment these labels go out, the culture in the class, the happiness in the class will go up. And that will only happen if we truly believe in it. It will not happen if we say it. There's an old saying which says that no child will ever listen to what their parents say, but every child will repeat what their parents do. So it's a bit like that. It is not about saying some of these things. It is about truly believing it, that we don't have to say it, but a child which felt unwelcome till now will start feeling welcome, and you don't know how the child is able to pick it up in our body language, because we truly believe that the child is welcome to the class. It doesn't really matter whether it is slow, fast, and any of these things. Because the most important thing in math learning is about brain plasticity, or about any learning is brain plasticity. Brain plasticity is simply this, that brain plasticity says that by doing deeper and deeper connections, by spending time on something, through dedication, through hard work, through effort, we will be able to mold and create new pathways and deeper and stronger connections. The deeper the connection, the more permanent it would be. The second thing it tells us is cognitive struggle. When faced with the problem, okay, let the child stay with the problem longer than we would like them to. Let them stay with the problem. We give a puzzle, let them stay with the problem. The answer itself is not important. The process of cognitive struggle, when we are going to try and solve a problem, the struggle we go through in our head. And if it's a non-judgmental environment, people enjoy going through that struggle. Why is that we like to solve crosswords or Sudoku or any of the puzzles? Simply because it is really joyous to be able to solve it. And it's not that if somebody comes out, when we are solving Sudoku, somebody comes out and says, you know what, I have the answer. You want to copy it and write it down? We'll say, no, I don't want it there. I want to solve it. Why is that we say we want to solve it? And where is the opportunity for our children to go through that cognitive struggle? We give a question and then out comes the answer. The gap between question and the answer is really the cognitive struggles space. And if that space is not expanded, learning really cannot happen, and definitely not deep learning. And in the process of doing all that, it is not necessary that they will be able to come out winners at all points in time. There might be sometimes wrong answers, sometimes there are imperfect methods, but that's all a part of growing up. That is all a part of the overall learning process. Okay, there is this nice story about London cab drivers. Let me be mindful of the time. Okay, I probably have 5 more minutes before I go into case study. Bama and Sendil will be taking us through. There is this nice story about cab drivers in London. Okay, there is a type of cab in London which is called a London cab, which is different from a private cab. It's a different looking cab, and the drivers of those cabs have to go through a test, and that test is called knowledge. That is the name of the test. Okay, they have to go through a test which is called knowledge, which basically checks as to, there are apparently 25,000 little streets and roads in London and various landmarks and buildings, and they should know every one of those things. And this particular question paper knowledge will test them on that, which is basically a huge test on memory. Later, what they did was, this is the experiment. They went and measured the hippocampus in the brain. Okay, hippocampus in the brain, which is the center for memory. They went and measured the hippocampus of London cab drivers and measured the hippocampus of other people like ourselves. And they found that the London cab drivers actually had a larger hippocampus. Can you believe this? The brain has actually changed through thought, effort, dedication. The brain has actually fundamentally changed. Right? If you want to change our structure of our body or chest or thighs or whatever it is, we have to do exercises. the cognitive struggle, the thinking, the deep learning, the conceptual thinking, the problem solving in an environment which is accepting and happy and creative is at the core of good learning of any subject, and specifically mathematics here. That is what we come to. Yeah. So with that, I will bring this part to a close, and I'm happy to take any questions you might have. We will take 2 or 3 questions maximum if you have some, and then we will go into the case studies, which Bama and Sendil will be. I will describe later as to what the case studies are all about. Yeah. Any questions at all? Oh, Sharad is saying that with the advent of Google Maps, now the new driver, the size of hippocampus was not that big.
So this was a study, Ramesh, done subsequent to what you're mentioning. This is a very important study with respect to these AI tools which have come.
Right.
And,
right.
And this is what is has been the finding.
Wow. Wow. So it just goes on to verify it in another way.
Yeah.
It makes it even, because sometimes I also wonder, is it like people with large hippocampus or the people who, pass the test called knowledge? Was there a selection bias in the whole thing? Was one question which used to kind of nag me. With this part of the study, not only have we proven, we have also disproven the opposite.
Correct.
Which makes the study even more scientifically rigorous.
Correct. Correct.
How do we diagnose math anxiety? Don't diagnose it. Just create an environment, Lalita, in your class where the children don't see. Children are very, very good in picking up non-verbal cues. Okay, which is why I keep focusing back, saying that we have to believe in some of these things. We cannot just keep saying these things. We have to truly internalize all of these things to the extent that we have believed so hard that there is no such thing called slow and fast learners. I'm not making a case saying that everybody learns at the same pace. Don't get me wrong. There is no benefit whatsoever about thinking about slow learners and fast learners. Okay. As a class teacher, this is something I tell in my pedagogical class. As a class teacher or as a teacher in a class, I always say that you think of yourself as a boatman, okay, or a boat person or whatever it is, as a boatman. And there are 20 people inside your boat. And we have to take this boat from one bank to the other bank. And all 20 have to get off at the other bank and happily. There is no joy in saying, you know what, 2 of these people in the boat, they become excellent swimmers. And what about the other 18? Oh, they all drowned and died. What is the fun in saying that? Our job as a teacher is not allow 18 kids to drown and die when 2 of them have gone on to get state ranks. Our job is that of a boatman, where we have to take the children from one bank to the other. Now, in the process, there might be some people who can swim. There might be some people who are seasick. There might be some people who are okay. And we have to figure out the little tactics rather than just labeling and saying good, bad, smart, slow, this, that, and all of that. Figure out our own little tactics. If we do that, and if the class environment is warm and welcoming and non-judgmental, Lalita, I can tell you math anxiety won't even creep in. So there is no need to diagnose it. It is a man-made problem. It is not a natural health condition of a child. It is a problem which we make as teachers. Okay, as long as we don't create the problem, there is no math anxiety in our class. There are plenty of math teachers whom we can all go back to our childhood and say, oh, this math teacher, it was so fun, to be in a math class. Why was that? Just the sheer fact the teacher was good. That's all we are hoping. There's no need to cure it, Pooja. It is again not a pathological condition in a child. As long as we are able to create a trusting environment in a classroom, a class where the children don't feel judged, an environment where the children are able to trust us, an environment where we are not labeling our children, An environment where we are not verbally or non-verbally communicating, the smart people are the ones who can do good in math. A place where all of this is absent will naturally be a happy place. There is no need to work on it. We just be this, okay? And the environment will be naturally without anxiety. There is no need to cure. It's not a pathological condition. It is not a disease the child has and the child has come into the classroom with a disease. The disease is created in the classroom. As long as the pathogens are kept away from the classroom, it's all fine. That's a good question, Pushpa. We will come to that in the 13th session. That simply means you have to wait for 12 more sessions. And then in the 13th session, we are going to come back and answer this one question. It's all okay for you to say creative and this one and, have fun and make it, making connections, provide some large gap between asking a question and an answer and everything else. But you know what? I have to get my children to score marks. I have to complete my syllabus. I have to complete my syllabus on time. And the parents are going to be all over me like a rash if the children don't perform in examinations. We will integrate the three and say the children can perform in an examination, you will be able to complete your syllabus and you will be able to complete it satisfactorily and yet be able to do it at a pace which is very gentle and something where the learning happens deeply. You know what we do? We will not, so try and understand this way. If there is a work which is half done and it takes 1 hour, then we have to rework on it, which will take another 1 hour. Then we have to rework and revise and do it one more time, which might take 1 more hour. While we have done the job, we have rushed through the job, which is why it wasn't finished in the first place. And then we tried to do some patchwork the second time around and the third time around. And finally, it took us 3 hours. All we are going to suggest is come up with ideas in such a way that we just have, it will take us more time, 1.5 hours instead of 1 hour. At the end of the 1.5 hours, there is no need for the other 1.5 hours. Or maybe we need some half an hour for practice. That is the way we are going to go about it. So we're going to do it right the first time. And there is no need for rework and doing it the second time and revising it and all that. There will be a bit of homework which we have to give. That's more of practice to solve and all that, but there is no going back to the same topic. I mean, if you take, there are topics which are addressed in 6th grade, 7th grade, 8th grade, same topic. If you go to data analysis, you will see the same thing is addressed in 6th, 7th, and 8th. Why? We do it right once. It can be in a 6th, 7th, 8th. Let's choose it, but just do it there. In the other grades, there is no need to do that. Okay, we'll come to all that in the 13th session. We'll come to all that in the 13th session. So in the interest of time, I'll stop the questions here. And Bama, if you're ready, I can share the case presentation.
Yeah, hi Ramesh, can you hear me?
Yes.
Yeah, so hi everyone. So I have a science club where, every week children
Bama, we
come.
can't see your full face. We can see your forehead, but not.
Oh, okay.
Yeah, now we can.
Now is it better? Yeah. Okay, so I have this, a science club or a math club where every week the children come and we do hands-on activities in both science and math. So I just want to talk about this one child who within a space of 1 year, maybe meeting about 30 times, we had these sessions, completely changed her attitude towards people and became more confident and so on. So what exactly I have here is in the science club, so what we do is I keep all the materials on the table and then I have some activities planned for them for that day, but then they are allowed to come the first few minutes. They are allowed to look at everything, and they are naturally, children are very curious, you don't have to, they ask so many questions and they are that is part of the nature. Every child is curious by nature, right? So they come and they look at everything. So this particular experiment was on density, so calculating density. So I had all this water, measuring cylinders, then these unit cubes made of different materials, metal, different kinds of metals, aluminum foil, wood pieces, and so on, and spring balances. And so the children come, they look at everything, they see how they work. And so we spend about 10 for the first 10-15 minutes, let the children explore. And this child, the first session, she came and she wouldn't talk, she just sat, she wouldn't do anything, she wouldn't interact with the children, she wouldn't do what I tell the children to do. And then after this, the subsequent, like third and the fourth sessions, the measuring cylinders are something very common. Like I used that in many of the sessions, right? It's just to measure water and any liquid. So I have these cylinders which are like 10 ml, 20 ml, then I have 50 ml and 100 ml cylinders. So for the children to play with. And so she used to come and not participate in the regular class, whatever was supposed to be, do whatever I did for that day. But then she used to play with these cylinders whenever they are around and keep measuring water in different ways and pour it and, all those kind of things. So at the end of the year, like around in February or something, I have this science exhibition where all the children take part. And usually I have a set of experiments for the children to choose from. So each one chooses an experiment, I mean, whatever they are interested in, and they try it out before, or they explore and they find out things, and then they come and present it on one day. So this child chose her own, like she came up with her own problem. And then her thing was like, given any number, like for example, I want to measure like 90 ml, right? So she could measure 90 ml in different ways. She could, either using the 50 ml cylinder, and then the 20 ml, 2 times 20 gets you 90. Or she can use a 100 ml cylinder and take out 10 ml using the 10 ml cylinder water, and then measure 90. And so on that day, like there are lots of parents who came around, lots of people who came around talking to the children. And she used to challenge the person. She used to say, okay, you tell me how much do you want to measure? And then if the parent says 120 or 200 or 180, she came up with a way that almost the least number of ways, least number of trials to. So if you measure 90, right, using 110 ml cylinders, you can do it in just 2 steps. Instead of 3 steps, if it is like 50 plus 20 plus 20 and so on. So in most cases, she could come up with a minimal number of steps to measure that particular quantity. And that was quite amazing. And then the confidence with which she spoke and with which she interacted with people, and, and the passion with which she conducted her experiment, that was also quite amazing to see. And her parents also told me, like, she was such an introvert in class. She never used to participate, and she has opened up so much in her regular classes as well. So this was a nice experience that I had. Thank you.
Yeah, it's so nice. And coming for the when the parents are visiting and still having the confidence to say that you challenge me, that that is really nice.
Yeah.
Super. Now this is an example of a case study. Okay. Now this case study, it is not necessary that you have to present a case, but if you have anything like this you would like to share. See, one of the main foundational principles of ECHO is all teach, all learn. This is not a training program which is a one-way street where somebody comes and gives gyan and somebody else is picking it up and going and trying to use it whichever way possible. There are things which we believe in, we share. There are many things which each one of us believe in and we want to share that. So as a community of math teachers, every one of us, there are 60, 70 of us here. And as a community of 50 or 60 math teachers, if you're all able to learn a little bit from each other, and grow as a math teacher. That is what we are hoping for. If we grow as a math teacher, both in terms of the pedagogical methods, the ways of teaching, the things to watch out for, if all of us grow as a math teacher, we believe that math learning will happen automatically. And therefore, all that anxiety and everything else will get sorted out on its own. There is no need to actually think directly about, oh, this girl has got math anxiety and that boy has got math anxiety. There is no need to think like that. All of that will sort out on its own if we correct the way we behave. So this entire thing is focused more as a self-directed way, in which case, what is that I can do as a math teacher for me to ensure that the children who go through my class don't later go through math anxiety in their life. They're not coming with math anxiety. Like Obama said, all children are naturally curious. All children are naturally interested in learning. As long as learning happens and it kind of caters to their curiosity and keeps it fun, they will naturally learn. There is no need to force anything at all. They will naturally learn. Okay. In fact, when I think when my child wasn't eating very well, and I had taken him to a pediatrician, and we asked, what should we do? Should we feed him something else? And he said, there is no need for doing all that. Let him just go hungry whenever he doesn't want to eat. And the next day he will start eating. That's it. There is no need to address a problem. Some of these problems are best left unaddressed because it will naturally find its own solution. Yeah. Thank you. Thank you, Bama. Sendil?
Hi, Ramesh.
Hi, Sendil.
So, thank you. Thanks for the session so far. One thing is, I wanted to go back to the slide where you showed the triangles and the triangular numbers and the square numbers.
Yeah.
Yeah. So it's a very interesting slide. So one thing what I also was wondering is, so say if we are listing down the numbers as 1, 4, 9, 16, 25 on one side, and the other side we list the numbers as 1, 3, 5, no, not 1, 3. It's and this triangular numbers.
Oops, your voice is breaking a little bit.
Very interesting to. Can you hear? Is it better? Okay, I can put the video off. Is it better?
Yes.
So it's what I understood recently, or by looking at a book, or I heard someone saying, it's very interesting. Say if we are taking the say the 8th square number 64, and we start with the minus of the previous square number. So 64 minus 49 plus 36 minus 25, 16 minus 9 plus 4 minus 1. It's interesting that you get the 8th triangular number. And similarly, any number to it. It's a fascinating thing to see these connections. And it'd be best done if we can just do this in class, and instead of giving them theorems, these are numbers in triangular are theorems at the class itself, as the class. So
your voice is still breaking, unfortunately. Sendil, your voice isn't coming through very well.
Is it better?
Yeah.
So
oh, no, not better. When you ask the question, is it better? It is better, and then after that, it reverts.
So the only thing is where where
really sorry, Sendil, to interrupt. It's really tough. We can't understand
Really,
almost nothing.
Is it better here?
No, sir.
It's slowly getting.
figure out
Continue talking, and I will keep interrupting till. Don't go into a point. Continue talking, and then I will.
No? Is it,
No, not yet.
if it's better, then I'll probably figure out a way, or I can put here. I'll put something. Just a second. I'll just figure out quickly. Give me 2 minutes. Give me two minutes time.
Sure. Yeah, because it's important that we are able to hear you well.
Yeah.
Yeah. Take your time.
Not audible.
No, I'm not talking.
audible.
I'm not talking.
He's
Just
not
a
talking
second.
yet.
Just a
He's just
second.
switching networks, I think. Let's give it a minute or so.
Yeah, just a second. Just a second.
Rakesh, is that your name, or your name is just Rakesh and just you're emphasizing it a bit?
Sir, my name is only Rakesh.
Okay. It says Rakesh. I can see there are some familiar faces, people who have been a part of our earlier program. There are many new faces, of course.
No,
I can
sir.
see Vignesh who's there. Yeah, there are a few familiar faces. Yeah.
Okay, is it any better?
Very much better.
Okay, so one thing what I wanted to convey is basically if we can allow children to have a feel of a mathematician, if we can allow children to create a theorem together, like what is a theorem? Theorem is a fact, but not just a fact, it's a special fact. What?
It's gone again.
It's gone again, Sandan. Now you're gone completely blank. Or maybe we can't hear us also.
Hi, sir. I want to ask some question.
Just hold on 1 second. Let's try and get Sendil.
I'm
was
not
halfway
really
through.
sure why it's really going this way.
Yeah, now it is fine.
Probably it's getting better and going off. So that is one thing. So one is that, can we have a position where children can feel like a mathematician? That is one thing. And the next is, you were talking about the math anxiety and how we can change that. There is one thing called the Pygmalion effect. Have you heard about that? Yeah, it's there in the Humankind from Rutger Bregman, where it was talking about the Rosenthal's psychological discovery, what he was doing. So it's a story where this scientist was called into a school to create some sort of a psychological improvement for the children. So he said, okay, I can do some assessment of what children are capable of and give the teachers a go, and teachers can assess their progress over a year. And they all gave some basic IQ test like anywhere else. And once the results are out, he just tore off all the answer sheets and he gave some random names. And he told that I'll come after a year and see whether my assessments are true and how did they perform.
Right.
And after a year, when he came back, it was so dramatic that whatever names he gave, those children performed extremely well because of the expectations from the teachers itself. It's not about their ability, it's nothing to do with their IQ or anything. It is purely because the teachers were expecting something positive out of them, they started doing positively. And that is the power of this Pygmalion effect. So the moment you start expecting something positive, children will perform better. This was
Right.
a test which was done in a lab among two rats. And it's a test which was done, and they were just told, some of the young scientists or the student scientists, they were told that you start analyzing these rats. One is obviously better. And just because they were expecting the rats to do better, the rats performed better. It was nothing to do with their ability. So that's the effect of what we can do. So in a math anxiety, if we can consciously go into the class with the thinking that everyone will do better, obviously they will end up doing better. So that is one thing which I really wanted to touch upon. And the next is, yeah, we can go to the case study. This is about a story of a favorite boy in a class. He definitely, this is something which I wrote about a year back, but now after knowing him much better, I knew that he definitely had difficulties in writing. He can't write, but he's so good with his physical abilities. And because he couldn't write, and not many teachers in his previous school or even in our school also, sometimes they don't understand. So he would be in a lot of stress, and he might not attend classes where they expect him to write. So of late, we have come to some sort of an understanding uh, with how to work with this boy. But now I'll explain about this thing. So when I start my math classes, I always start with number dictations. And these number dictations are something where I would start by giving 2-digit numbers or 4-digit numbers or 5-digit numbers, and it will keep going based on the ability of the class. I do this from grades 2 to almost like grade 10, where in every case I would give some time to think and then some time to write. But this boy, because it is writing, he wouldn't come. Uh, so initially it was so tough for me to make him move, because there is one round circular window in our class where there are no grills or nothing. So you can just go there and sit curling up and start reading a book. Nobody would feel disturbed, or you won't get disturbed by anyone else. You can happily read. So this boy would go there and start staying there and taking a book. But the thing is, how do I make him come? And how do I make him come and do the work without him getting exposed for not following certain so-called rules of the class? So, but he's so good at mental math orally, which he would want to tell it loud and clear in the class while others were writing. That's also disturbing the class. So I asked him, okay, Alec, if you can just go and pick your book in exactly 3 plus 4 plus 5 steps. So now that he faced that, it's a good challenge for him that I have to do the addition first quickly, and also go and take the book in exactly that many steps, not one more, not one less. And it's not so far. How would he take exactly those many steps, like 12 steps? So he started, I was thinking probably he would take a longer route or he would take smaller steps. He was just walking as close as possible, and suddenly he would take very small steps. I thought he would not even reach it, but towards the end, he jumped in exactly the remaining 2 steps and he took the book. And the whole class was in loud, cheerful, joyous mood, which gave him a very positive feel. And he would take the book, but again, he's not really ready to write. So I asked him to sit next to me. You tell me the numbers exactly what I should write. Say if I would say 7002, you can't tell me 7002. You have to tell me what digits are they, like 7002. Sometimes what children do at the third grade level or second grade level is, when I say 7002, they write 7 3 zeros and a 2. But if you tell me 7002, I'll write it for you. And some numbers, I'll tell him, okay, alternate numbers, let me write one number and you write the other number. If you have a mistake, then I'll change or something like that. And it was more like a game, and I would ensure that he was also respected, and he knew that he could enjoy in the class. Some math problems he would do it, some problems he would explain me orally, and I will help him do this. And if someone finishes quickly in the class, I pair them up with him. And so it was always that if we could ensure that the child is not put down in front of the class, I think we are with the child. Yeah.
Right. Yeah. Beautiful. Awesome story. Yeah. Yeah. No, this is amazing, Sendel. Thank you. Thank you for sharing that. Now, so these are all case studies. So if you have any case studies you want to share, please do share, and we will try and see whether we can take it up. We can't promise we'll be able to take up all the case studies, but if you want to share, please share that so that all of us can learn from those experiences, right? Now, going forward, next 10 minutes, we'll wrap it up. Now, this is what a structure of a session will look like. Each of these sessions are going to be for 90 minutes. There will be, the first 5 minutes and the last 5 minutes we need for wrap up, feedbacks, Q&A and stuff like that. And in the first, getting the login right and any introduction, any chit chat about the previous session, all of that will happen. And then we will move into discussion of some questions we would have asked in the previous session. So next session, when you come, we will spend the first 20 to 30 minutes on discussing a previous session's questions. Okay, I will post the questions for this session at the end of this particular session in about 7-8 minutes. And then we will take a didactic. A didactic is where we will take one topic, typically from 0 to 5th grade, 6th, 7th, 8th grade, 9th, 10th, because these are like logical pieces. 0 to 5 is a very similar kind of, thinking when it comes to the classroom, and children are pre-adolescent, and the emotional connection with them is very important. So 0 to 5, sort of the pedagogical methods and the subject kind of goes together. And then 6, 7, 8 is a bit different, and 9th and 10th is a bit different. So we will take some idea and discuss it. Then we will probably from time to time, we will also have one pedagogical concept, which we will cover. You will know what that is when you come to the first session in a week's time from now on the 9th of June, 5 to 6:30. And in terms of topics, we're going to be covering a whole bunch of topics. We will spend some time on arithmetic, something on data handling probability, mensuration, ratio proportion, progression, geometry, trigonometry, all kinds of things we will be covering during the 13 sessions. We will also be covering simultaneously and all woven into the whole session itself would be, what are the kind of math manipulatives we can use? How can we bring origami into our classrooms? What are the kinds of games and puzzles we can have? How do we explore a certain topic? And are there any approaches to how we can explore a topic? If you are given a topic, let's say, what is this? And how do we start exploring that as a classroom? The part which Sendel was talking about, how do we make all our children feel like mathematicians? They're explorers, they're mathematicians who are exploring it in the classroom. And that's really fun, because what they come into the classroom with is curiosity. And what we have to give them is an opportunity to explore. Curiosity and exploration is a beautiful classroom. If you give them answers, then it doesn't quite go into a very happy classroom at all. So a typical session could be something like this, how do we build intuition about an unknown? If we take a topic like algebra, when we have an idea called an unknown, we can call that unknown as a or a B or a C or an X. We don't necessarily need to introduce it in the first class. How do we build the intuition about an idea called an unknown? And then slowly from there, How do we make them imagine algebra? Rather than solving it as just equations, can we imagine that as a graph? Can we understand algebra in a physical form? And then slowly take them to quadratic equations and so on and so forth. And we will be handling real life questions, which we can solve at a certain amount of depth. Right. So that brings to close the first session. The topic on which this is mandatory, all of you will try and identify, it won't take you more than 5 minutes, identify 2 or 3 topics where you as a math teacher felt the kids started losing interest. It could be that we can say that, the kids used to be so energized when they were doing addition and subtraction, but the moment it came to division, they kind of started withdrawing and going off. Is there something we can do when it comes to division? How do we introduce that idea called division? So we can ask those questions. First is to identify 2 or 3 topics where the kids start losing interest in mathematics. So we get an idea of what are those areas we need to focus on and what are the areas which we need to stress on as a hub team. The second one is what, according to you, are some reasons why children slowly start disliking mathematics. This will call for a certain amount of introspection. It will call for a certain amount of honesty in the introspection. Again, don't feel like, because sometimes either through self-judgment or an imagined peer pressure will not allow us to come out honestly with our introspection. So this, we have to all treat it as a confidential safe space where we should be able to share our thoughts and feelings quite openly and say, these are the reasons why I think children slowly start disliking mathematics. Maybe I could do it this way. Okay, it is a self-directed mechanism. So we as teachers have to kind of reflect on what is that I could do differently. What are some of the things where, why do I think they start disliking mathematics at some point in time? And we will take that as both of these questions, identifying the 2 or 3 topics where they lose interest in mathematics, and also where is that they start disliking mathematics. And that is what we will do when we say discussion of previous sessions questions. These are the 2 questions we will discuss. We'll have plenty of time to discuss, and all of you please write in your thoughts, ideas, feedback on those 2 questions, which Mary, Nadia, Rahul will be able to share on the WhatsApp group, which we have set up for this. And on the WhatsApp group, they will be able to share that. And please, it won't take more than 5 minutes of your time. And some of you, if you want to present a case, do send it to us about a child or about a mathematical concept, any of that. You please share it with us so that we are able to take it up and slot it in and be able to prepare for that. All right. So thank you very much. We have another, well, let's say 10 more minutes for Q&A. I'll stop sharing the screen. If you have any questions, on topic, off topic, it doesn't matter. Yes, Nadia.
I wanted to talk about the pre-test. If you could please ask them, I'll just share it right away then.
Yeah. So there is a pre-test and a post-test. We want to give a pre-test and quickly do answer that. Don't spend too much time thinking about each of those questions. Whatever comes as a top of the mind recall, just quickly answer it that way. It's a test more in terms of our current belief system. And then hopefully over the next 13 sessions, we would have made a dent on that belief system, and that we will measure it as a post-test, which will give us some amount of understanding in terms of the efficacy of the program. All right. Any questions at all? If whoever can put on their videos, turn on their videos, please do that. So we kind of know that everyone is there. Yeah. Any questions at all, please feel free to. It doesn't have to be on today's sessions. It can be anything you can ask. It could be about the program. It could be about us as individuals.
Sir, can I ask a
Yes, Namita. By way of introduction, very quickly, there are three of us. Sendil is a full-time math as well as passionate in terms of learning, teaching, and all of that. He works out of a school called Marudam in Thiruvannamalai, which is a farm school and alternate school. Bama and I are not full-time teachers. Both of us are, quarter, semi, half, three-fourths retired kind of folks. But we are both passionate as far as mathematics is concerned, and we have been volunteer teachers in multiple schools and programs. And all three of us have generally been engaged in many of the math-related activities. I mean, we go and do training in schools for teachers. Sometimes we run these online programs. Yeah, that's pretty much who we are. In terms of our past life, you can go and look up LinkedIn or something like that. Yeah. Yes, go on Namita, right? Namrata or Namita?
Yeah, Namita.
Namita,
Thank you
yes.
for introducing yourself and your team. We are also passionate about mathematics, but my doubt as an individual is that you're giving us so much knowledge and you're working hard so much on the presentations. Why are you doing it for free?
Yeah. In fact, Namita, that's a good question. I have Aditi. I can see Aditi who has turned on her video, unfortunately. Till this time, I didn't know Aditi was here. I've always said that we should be charging 500 rupees per person for this program, which will be donated to a cause of our liking. Okay, there are plenty of schools and children who can do with a little bit of financial support. If we can't do anything else, at least we can do the easiest one, which is a financial support. So I did suggest to Aditi that we should charge a little bit of a token sum. It puts a certain amount of commitment in us, and also it will go towards, at least financially, if not anything else, help out a little bit with kids who are otherwise financially struggling with. Yeah. Wonderful, Namita. We want you to be there for all 13 sessions.
So I have one more question, if you
Yeah.
allow me to ask.
Yes.
I teach at a government school, and children there have a very everybody is aware about their backgrounds, their difficulties in their daily life, and their financial issues. So the problem is that they are not able to focus very well in the classrooms. We try to, it's not like we have funds issues now in schools. I would not say that government schools are suffering from a problem of teaching aids or any other sort of aid that we need from the government. We are getting it pretty well, but the children are not able to focus well towards being committed to studies, and especially towards mathematics, science, and English. So for mathematics in particular, because we are dealing in this session, what would you suggest, or maybe in the next session we can take up this topic, that why are they like that, and how can we, because I keep telling them that it is very useful for them, but when it comes to algebra, probability, and little abstract concepts of mathematics, they lose interest. So I kind of find it challenging for them to focus and do well. They can, I know they have the potential, but their focus is the problem. Thank you.
Yeah. Namita, can you do me this one small favor? If you can write down what you have just said in maybe a short paragraph, we will definitely take it up. Sendil has plenty of experience in this space, and so does Bama. I would request Bama and Sendil to give you their thoughts and share their thoughts in terms of what can be potentially, how do we approach something like this? Okay, it's a complex problem. What you're saying, it is not so much about mathematics per se. It's a more complex problem, and we need a more wholesome answer, which will probably take, say, 10 minutes to really provide that answer. And we probably don't have that luxury right now, but we'll definitely take it up, Namita. Please do share that as a short paragraph and share it with both Mary and Nadia.
Thank you. Yes, definitely.
Nadia and Mary will be a go-to people. Mary is will be leaving, and she will be going off in a few weeks' time. So Nadia will be our point person for now till we find a coordinator for this particular program. Yeah. So just yeah, Nadia, who is very much there, and she will. Ruchi, go on.
Good evening, all. My question right now here is ki I have worked as a teacher as well as a teacher educator. Right now, I'm working on the major problem I faced during all these scenarios, or I should say all these experiences of my life, is like when we talk about teaching process or teaching learning process, we usually believe that there is a one standard procedure that has to be taught to the students, and that belief is passing on from generations to generation. We don't give scope of learning or exploring in the classrooms. Even if we give that scope, still we stuck to a standardized procedure or a standardized method of solving a problem. For example, if we talk about addition or division, like if I talk about division, तो division जब हम करने की बात करते हैं तो वो जो umbrella वाला process है, that is the standardized process that is to be followed throughout in all the schools. And if the child deviates from that or do something other way out to solve the problem, it is not corrected. This sort of mindset, how should we challenge that? Not only for the students, it has to be challenged, I think, somewhere at a level where teacher education is taken care of. So
Yeah.
how that mindset required to be changed. And
Yeah.
secondly, maths is abstract in nature, of course. The same problem arises with the lower graders, that it is introduced very I should say rudely or mechanically to them also, and there also they won't get that exploration. So how that things to be sorted out, because now we have reached to the FLN situation where we need to focus right now.
Yeah. So Ruchi, hopefully during the sessions, the next 12, 13 sessions we have, some of those questions will get answered, what you're saying. How can we do it in a method which is engaging, which is creative, which is fun, which is making the children appreciate the beauty of mathematics. But the point you're saying in terms of how do we change the system and the society, that is not something we can work on directly. So we have to all understand as individuals, as long as I change and I become a champion of that change, and I'm able to influence a small sphere of people around me with that particular change, and I'm able to do that without putting the I and the ego in front of all of these things, then the change will happen. It will be a slow process, but it will happen. But what do I change? What are the different ways I can introduce a certain topic? That we are going to discuss anyway. But because okay, I always tell this little story when somebody asks a question of this nature. But let me take 1 minute to say that very quickly. See, there's this old lady who used to go to a lake, and she used to go there every Sunday morning and spend 2 hours doing something. And she will after that go back. She used to come to the lake with a bucket and a few other small things, and then she will be there for 2 hours, and then she will go back. And the policeman who does the beat in that particular place used to wonder, what is this old lady coming every Saturday or Sunday? Every Sunday she comes and then carries this bucket and comes and does something in the lake, and I don't know what she does, and she goes back. So one day he goes up to the lady and asks her, old lady, I mean, I know you're doing something, you're creating no disturbance or nuisance. Feel free to continue doing that, but I'm just curious, what is that you do? So she says, no, you know what? There are a lot of turtles in this lake, and the algae forms on the top of the turtle. And when algae forms on the top of a turtle, they can't swim and get food. And if they can't swim well and get food, slowly over a period of time, they become weak and die. So what I do is I pick up a turtle, scrub off the algae, which is at the back of a turtle, and put the algae back and put the turtle back in the water. And then I pick up another turtle, scrub off the algae at the back of the turtle, and put it back in the water. So the policeman is quite moved by all this, but he does ask the obvious question. He says, you know what? There are so many turtles inside the lake. How are you going to bring about a change? The old lady says, no, that's not the way to look at it. You go and ask the turtle. I made a world of a difference to it. Okay, so we just think of one turtle at a time, period. We don't have to think in terms of how do I solve the societal problem. That WhatsApp will take care of it. You know, all the random fights which happen. So we as teachers, we have to just do 3, 4 things right. 1, I have to change my belief system as a teacher. 2, I have to learn new methods as a teacher. 3, I have to own whatever I'm learning as my own when I take it to a classroom. 4, I influence the people around me in terms of what my teaching methods are. And in doing that, I don't bring the I and put it in the center. I take the cause and make that my passion and say, this is what I want the change to happen as beautiful math learning happens. I made it happen is not relevant. The I itself is something which is going to perish in a few years. What we want to do is beautiful math learning to happen over time. If that happens, and if 70 of us who are sitting in this particular place, and each one of us is able to influence even 5, 10 people, and each one of them is going to do that, the effect will be viral, trust me. That's all. We have to look for our turtles and take the algae off the turtle, and that's it. The society can take care of itself. It will over a period of time. Yes, Suma. Wait, I need my spectacles. Sunita.
Hello, sir. Good evening.
Hi, Sunita.
So one quick question. Is there any program that you deliver directly to the students in school?
No, not right now.
Okay. Are you planning to come up with one?
We can do teacher training. See what happens with children, right? I mean, a few sample classes we can do, but it will be a sample. That's it. Because what happens is there are 2, 3 things which happen. One is we might end up hijacking the relationship between the teacher and the student. One has to be very, very careful when we come in as an external trainer. It should not disrupt the relationship the teacher has with the children. And that relationship is sacred. And it's very, very important for the trainer to be sensitive of that particular relationship so that the person is able to act as a aid and a helper to the whole process rather than somebody who's sitting on a high horse and delivering lectures on what it is. 2, in terms of impact, it might not be that impactful to do directly with the students. We don't have that kind of bandwidth also as individuals. But if some of you get inspired and you put together a program and want us to be a part of a program of that nature in terms of, guiding the whole process in whatever way we can, I think we can definitely do that. But directly doing with the, because when you do a good program with a teacher and the teacher is able to take it into her class and truly own what is being spoken or talked about here, then what happens is she's going to be in the school for 20, 30 years, and every year she's going to teach 50 children. So making an impact on one teacher is the same as making an impact on 1,000 children. Okay, and that's our hope. And if you are able to make an impact on a few teachers, and the impact will be huge, because there's a lot more to learning than just syllabus and classroom and classroom management and lesson plans and everything else. First and foremost is the engagement, right? I mean, so that can never happen from a trainer. A trainer is a third party. No trainer can ever. They can come and give gyan on how to solve algebraic equation. That is different. That we can tell the teachers themselves. With a child, we have to engage the child.
Yeah.
I am actually a principal of a school, and from my experience, I have to tell you,
I gathered that.
We always bring in experts to train my teachers, but apparently teachers do leave, and every time they leave, we lost what we invested in.
What we can suggest to you, Sunita, what we can suggest is, even now it's not too late. If you want some of your math teachers to be a part of this program, ask them to feel free and jump in and be a part of this program. That would be very helpful. And once they get familiarized with what we discuss here, at some point in time, we can address a group of teachers separately for your school. Maybe 2 or 3 sessions we can do. And yeah.
All right, great. Thank you, sir.
Okay. So one last question from Pooja before we wrap up, because we are already 3 minutes late.
Good evening, sir. I wanted to just know, is it possible if we miss out any session, can it be replayed, something like that?
There will be recording if you miss out a session. But you know what? We cannot have that engaging conversation we could have in a session. So a recording is a poor substitute for being a part of the session. So I will strongly encourage you, Pooja, to somehow put it in your calendar. I know all teachers are
No,
always
I'm
busy.
not telling I'll be absent or something like that, because so many times we will have some other occasions where we are supposed to, like, we cannot attend. If that is the case, we'll be missing
be a
out all
recording.
the valuable feedbacks or whatever
Yeah.
discussions we are getting in this
Yeah, there will be
program,
a
right,
recording.
sir? So
Yeah,
because it's
all
not
programs are
a
recorded.
1 or 2 sessions we have, which is almost like half year like length this one program. So in case if we miss out any program, is it possible that we get the thing, like recorded thing, to be played in the WhatsApp group or something like that?
We have the recording. The recordings will be shared as well. It will not be shared immediately. As soon as it's ready, it will be shared. It takes a few days.
Thank you so much, sir.
Despite saying Pooja's is the last question, given it's a raised hand, I feel I'm obligated to ask Lata what her question is.
I'm sorry, I couldn't resist myself. The only thing I wanted to know is, will you be providing any exposure to the materials that can be used for kids as such?
So if the question is, will we be providing worksheets and
No, I'm not talking about worksheets as such. It's
Mhm.
mostly about the concrete materials which will be helpful for kids to learn math in a fun way.
Yeah. We will share some thoughts. See, what we are doing is we are trying to work at a thought and a belief system level, where we will share some thoughts in terms of how we can approach arithmetic. When you come to first session, no, Lata, we will be able to probably, you will understand where we are going with it.
Okay, thank you so much.
All right. Okay, super. Thank you. Rakesh, I know you raised your hand and dropped it down. If you can post your question on WhatsApp, we will try and answer it there.
Only I want to say one thing, sir. Can I get this video in Hindi language, sir?
None of the hub members, none of the three of us are proficient in Hindi. And therefore, you might have to listen to it in English only. Nadia Aditi hopefully can help you with the process of translation. I don't know how that is done. None of the three of us know a word of Hindi. So, or we will know very little, let's put it that way. Otherwise, Mama is going to kill me. So,
I will try to understand.
yeah. All three of us are not proficient in Hindi to be able to teach effectively in Hindi. Yeah. All righty, take care. Bye-bye. Cheers. See you all in a
Thank you
week's
so
time.
much.
Yeah.
Thank you so much.
Thank you,
so much,
Nadia.
sir.
Bye-bye.
Thank you.
Thank you, sir. Thank you so much.
very much. Thank you so much. Thank you so much, everyone.
Thank you, sir. Thank you, sir.
Request everyone to please fill the feedback form. We'll be sharing the link in the group as well. Thank you.
Okay, ma'am.
Thank you.
Bye.
Thank you, sir. Thank you, ma'am.